Welcome to Spring LIB.
Hello everyone, today we're doing chapter 18, problem 30, and this problem asks us to synthesize these two compounds starting from benzene in 2 steps. So we know that we're starting from benzene ring, 6 carbons, and we are adding some sort of carbon or straight chain carbon or branch carbon substituent to our benzene ring. So we have 2 methods to do this, one of them being Friedel-Crafts acylation, one being Friedel-Crafts alkylation. So obviously the easiest step is just to add the straight chain alkyl group here, but then we could do the conversion in 1 step. So this question though is asking us to do it in 2 steps. So we got to use Friedel-Crafts acylation followed by reduction of the ketone to form the straight chain alkane. So starting from benzene, we need to see how many carbons we're adding. So we're adding 1, 2, 3, 4, 5. So I'll draw those 5 carbons. So 1, 2, 3, 4, 5. And now we need to make this an acyl group. So at the very terminal carbon, I'll add my acyl group, and this will be an acyl chloride. Now I need to add my Friedel-Crafts acylation reagent, which is a loose acid, which is aluminum trichloride. And we know that through electrophilic aromatic substitution, the benzene will be our nucleophile, this carbonyl carbon is our electrophile, and it will be converted into a carbocation, and the benzene will attack this to add on this acyl group with 1, 2, 3, 4, 5 carbons. But now we need to reduce this such that we remove the oxygen double bond oxygen and we get a straight chain alkane. And we know that from the textbook, some reducing agents, there's several, but we can use zinc with mercury in some sort of strong acid like HCl. And this will fully reduce this into our straight chain alkane with 5 carbons, being 1, 2, 3, 4, 5. And then using the exact same process as the first example, we can convert this benzene to this terbutyl group here. So we need to count how many carbons we need to add. So we are adding that terbutyl plus this extra one here. So we'll add the acyl group off of this carbon. And now we're adding the aluminum trichloride for the Friedel-Crafts acylation loose acid. And then we get the acylated product being this. But I'm going to reduce the ketone using the same reagents here. Zinc, mercury, strong acid. And we are left with our hydrocarbon product. Remember, this is in 2 steps. That's what the question wanted, but we could have all done this in 1 step by using some sort of Friedel-Crafts alkylation, but then we would run into the problem of getting an isomeric mixture of products because this would form a primary carbocation, which would then probably go through a 1,2 hydride shift to form a more stable secondary carbocation. So you would most likely get a messier reaction and messier or multiple products. So this way is a very good way to just isolate one product and exclusively one product with no minor products or no side products being formed.